Rich Trani with TMC here. Thanks for watching. We're at the Javits Center today. We're conducting some interviews with some of the best and brightest companies that we could find in the area. And so on our program right now is Bob Twitchell. He is the president and CEO of Dispersive Technologies. Welcome to the show.
Thanks.
So I figure we start off by discussing a little bit about what your company does and some of the new things that you've announced.
Yeah, basically we're a software networking company, and we've come out with some new technology that allows us to dramatically improve performance, reliability, and security on the internet.
So tell me a little bit about that. How do you make that happen?
Basically, it's virtualizing routing. There's been a lot of discussion about how to virtualize routing on the internet, and at the end of the day, we're able to do what a lot of people do inside NOCs. We can do out in the open internet, and essentially what we're doing is maybe a good way to visualize is split traffic. The internet sends data one path, finds the quickest path, sends all the data that way. Security problems like man in the middle end up grabbing that data, and what we do is we split it up, thereby making it difficult for them to capture all the data. But by splitting it up, we also get more paths, we get more reliable, and then we get faster.
So by splitting it, you are faster. Could you go into a little bit more detail on how that happens?
Sure. Whenever you start a session, say I'm doing a video conference with somebody overseas, and if you notice a lot of times when you use that, the connection will slow down, it drops sometimes, and then you have to reestablish it. What we do is we create independent paths on the internet by deflecting through servers, computers, and mobile phones, splitting the traffic up and forcing these independent paths so that if one slows down, if one gets congested and drops, the other two are still up. And when you split that traffic up, you get, like I said, the ability to beat man in the middle because you can only capture a third of the traffic. You get faster because when one's down, the other two are still up. The user doesn't notice any of this stuff. It all happens behind the scenes.
So I've heard the term triplication before. Is that data triplication? Is that kind of like what you're doing?
No, that's probably about the opposite of what we do. We are setting up the independent paths and splitting the session layer up without duplicating, triplicating any of the traffic. So when we send the data, some of the traffic may go down path 1, some of the traffic down 2, some of the traffic down 3, and then we mix them around. And then on top of it, we can do something called roll. So we can roll the connections so that we can continually keep all three connections fast.
Now,
no triplication of data.
Okay, so no triplication. So just the opposite, in fact. So how does this play into some of the hot buzzwords in the technology space, such as SDN and NFV? I know it sounds a little bit like SDN, but is NFV in play here?
Well, SDN basically does a great job of trying to improve the costs and benefits inside the NOC. When you look at NFV, which is network function virtualization, it's basically trying to speed up the application side on the device. With our technology, we're kind of the missing link. We're in the middle. We're actually helping an application, say, for example, that you and I would want to be connecting over like video conferencing or file transfer or whatever we're doing. Basically, we're providing that coverage in the missing link, which is the open internet itself.
Okay, and so your technology is available via, is it some proprietary hardware? Is it open? How does that work? Open, like PC-based, server-based?
Our software runs on essentially all of the common platforms. Android runs on Mac, iOS, it runs on Windows, Solaris, pretty much all of it. We are a 100% software solution, no hardware base.
So I'm sure someone watching this right now would be thinking, okay, he's said that he can defeat a man-in-the-middle attack. Can he prove it? How would that work? Can you?
Yeah,
what would you say?
We've been red teamed 3 times, a couple times by the government, and successfully passed the man-in-the-middle test every time.
Now, what about speed? How can you tell the viewers right now that you're faster or prove that?
Well, you know, the speed is one of those things where when the network is quick, I don't notice it because things are working. You notice it when the network slows down. The only thing I can tell you is we've had customers who, for example, were running out of North Carolina over a fiber, over the internet, over the mobile phone network, over Wi-Fi to a laptop in a workstation area. And essentially they were seeing 3 to 5x improvement in speed. And this is not compression. This is just the raw data. And a lot of it has to do with, like, for example, if you're working on a busy hour for the internet, that busy hour has a lot of more congestion of the routers. Routers are losing data, the TCP links have to reform. Well, with ours, we've got these independent paths, which are multiple links. So think of it as having parallel paths, all sending your data whenever they're available. And it's those being up, where some of them are being congested, but not all. And our ability to roll to make the network stay fresh, which allows that speed improvement.
Excellent. What else should we know?
Well, the name of the company is Dispersive Technologies. The software, we're a small company, but we have some larger customers now, and we're available.
Fantastic. Thanks for being on the program.
All right, thanks.